Hello chemistry students. In this video I'm going to go over just the basics of what stoichiometry is. This is one of my favorite topics in chemistry and also one of the most useful things that chemistry does in the real world is give us a way to predict how much stuff you're going to get when you do a reaction. So stoichiometry uses a balanced equation to relate the amounts of compounds involved in a reaction to each other. You learn how to balance equations, and that's going to be very important for the stoichiometry of the reactions. So you might notice that this reaction example that's given here is not balanced. So let's take a moment to balance it. So there's two nitrogens here, so in order to get 2 over here we'd need to add a coefficient of 2. Then that would give us 6 hydrogens, so we would need to add a coefficient of 3 here to get 6 hydrogens. Now it's balanced. And effectively what this says is that 1 molecule of nitrogen reacts with 3 molecules of hydrogen to make 2 molecules of ammonia. Now, another way to state that, since molecules and moles are proportional to each other, is that 1 mole of nitrogen reacts with 3 moles of hydrogen to make 2 moles of ammonia. Alright, that gives us a mole ratio. So the coefficients from the balanced chemical equation make a ratio that relates the number of moles of one substance to the number of moles of another substance. So for example, if you have 1 mole of nitrogen, then at most you could make 2 moles of NH3. Here's how we would write that as a ratio, say like if we were using dimensional analysis or train tracks, as you might know them, to do this. So if we were converting from an amount of nitrogen to an amount of ammonia, then we could do something like this. On the bottom of the conversion factor, we'd put 1 mole of nitrogen, and on the top we would put 2 moles of ammonia. Or if we were trying to convert from ammonia to nitrogen, we would do the opposite of that. This might seem very similar to what we did in the mole unit, and it is. It's just another step. So the only thing that's different here is instead of making conversions amongst all the same compound, now we're going to convert from an amount of one compound to an amount of another compound. Alright, so here's some of the types of questions that you might be able to answer with something, how much product can be made from a certain amount of reactants, how much reactant would it take to make a certain amount of product, and how much of reactant A should be combined with reactant B to make a certain amount of the product. All of these things would be very, very useful calculations in industrial processes where it's necessary to know how much stuff you need to start with to make the desired amount of product. Thanks for watching.